Okay, good afternoon. This is the teacher Tuhire Isaac, who is going to take you through set theory, the entire topic. And set theory is under the element of construct, data, and probability. So I request that you pay attention, you watch this video, learn something, pause, note down some things, such that you get what we are going to discuss in this video. So I'm teacher Tuhire Isaac, a teacher of mathematics in O level, and then I teach pure math at A level. So under this topic of set theory, we have some keywords. And one of our keywords is complement. As you know that in sets, the moment they say shade set A, complement means that you are not going to shade set A. So the moment you see that word complement, it means that that set is not part. The moment I say shade A intersection B bracket complement means that as you are shading, that A intersection B is not going to be shaded. So that is our first word, complement. And the second word, keyword, is disjoint. Disjoint sets are sets with no members in common. I may have set A as 1, 2, 3, 4, 5, and then set B I have A, B, C, D, E, F. When you come to find common elements A intersection B, you will not get any element belonging to A intersection B. It means that A intersection B will be an empty set. And that means that there isn't any common member in those two sets. So the moment they say they give the relationship between two sets, if at all they don't share members in common, we say that the three sets are disjoint. Then we have also element all member of. So member elements, those are the things found in a set, all members of a set. Now if I say that set A is a set of vowel letters, then it means that A, E, O, U, all A, E, I, O, U are the elements of set A. So there now, we say that those elements found in that set are what we call elements or members of sets. Then we have also equal sets. So for the case of equal sets, those are the types of sets with the same kind of elements and exactly of the same number. So I can define equal sets as the type of sets with same number of elements and of the same kind. If I have set A having A, B, C, D, and also I have set B having A, B, C, D, small letters, then it means that the two sets are what? Are equal. Then we have also equivalent sets. So equivalent sets are sets with the same number of elements but of different kind. An example, I may have set A. Like set A has 1, 2, 3, 4, and then set B has A, B, C, D. You can see that the number of elements in set A is 4, and also number of elements in set B is also 4. But those 4 elements are different. I have 1, 2, 3, 4 in set A and A, B, C, D in set B. However much they are 4 in number, but they are different. And we say that those two sets are called equivalent sets. Then we have also intersection set. Now that is just a set of common elements. I believe that one is very familiar to you. Then we have null set or an empty set. An empty set is a set with no elements or without a member. An example, if I say that set A is a set of birds with 4 legs. However much you are hearing 4 birds, all birds with 4 legs, but it cannot happen. There isn't any bird with 4 legs. So we say that that set is an empty set. Also, I can say that set A is a set of 10 men breastfeeding babies. But in actual sense, men do not breastfeed babies. So that's why we say that empty set is a set without elements. Then we have a set itself, just a group of well-defined elements. But you have to make sure that the elements are the things are well grouped and they must be similar. An example, in markets, we find mangoes alone, tomatoes alone, because you can see that those are similar things. You cannot group oranges with tomatoes, never. If they are selling those tomatoes, they sell tomatoes alone, they sell onions alone, they sell apples alone, but never can you find a group of mangoes with the pineapple with the apples at the same time. So we say that a set is a group of well-defined elements. Then we have subset. A subset is a small set contained in a big set. All small set got from a big set or a mother set. Now here we have what we call, if I have a set, maybe set A is having 1, 2, 3. Now that set A has 3 items, so you expect 8 subsets. If I say that, draw a Venn diagram to show that all cows are animals, it means that from all animals that we have, also we have cows. So you draw a Venn diagram having cows out, having animals out, and then the set for cows inside animals. Because you can say that cows can be got from animals, having different types of animals. So subset is a small set got from a big set. Then we have union set. As you hear, the word union comes from the word unite. So union set is a set combining 2 or more sets. Is a set combining elements of 2 or more sets. I can have a set A, I can have set B, at the same time I can have set C. But I can form one set, have one set for all those 3 sets, and that's what we call union set. Then here universal set is also part. So universal is a set of all considered elements. Even I may have elements of set A, and also I may have elements of set B, and even some elements which do not belong to any of those 2 sets. So we say that that's a set combining all those elements is what we call universal set. Then by end of this topic, learners should be able to at least describe a set and identify the elements in that set. Then also we have identify different types of sets and their symbols: empty set, universal set, complement set, disjoint set, intersection set, union set, and then subset. Determine the number of elements in each set. And also, a learner should be able to represent and show different operations on sets by shading the different regions on a Venn diagram. Apply sets in practical situations using 2 and 3 sets. And that's what we are going to look at, that learning outcome number 5. Apply sets in practical situations using 2 and 3 sets. This first part of sets in this new curriculum, we may not be told to shade, but it helps us understand different regions. But now we want to focus more on that learning outcome number 4. Apply sets in practical situations using 2 and 3 sets. But for the case of 2 sets, we learned that one in primary 6 and primary 7. So now in secondary, we mostly focus on the 3 sets. And so what we are going to look at today, then other learning outcomes will come in other lessons. But I still believe that we can all excel in mathematics. Don't forget to subscribe. Just subscribe to see so that you can keep seeing notifications for the new lessons that we shall have produced and uploaded on our YouTube channel. Then also we want to see how are sets important in our day-to-day life. So, number 1, sets have various applications in different fields, including mathematics, engineering, statistics, probability, and computer science. Then also there are some specific problem solving strategies using sets, such as using Venn diagram to visualize the set relationship and identify the patterns. So we use Venn diagrams to show the relationship between the 2 sets. And also we have applying set operations like union, intersection, difference to solve problems. Like when you are extracting your information in the scenario, I see people using A intersection B, A union B, A intersection B bracket complement, A intersection B complement, intersection C complement. Now all those we are going to see them. So as we are applying sets in practical situations, we have to use those set operations. Then also representing problems using set notation and to clarify and simplify problem solving process. So these are the 3 sets, and I request that kindly see how I'm going to describe different regions. So now this symbol is for universal. This symbol is for universal, and this one here, and then the whole of this is set A. Then the whole of this is set C. So this region, this one, and this one make up set C. Then the whole of these 4 regions, this one, and this one, make set B. But how can this is A only, then this is B only, then this one is C only. Then these ones here for 2. This is for A and B only, A and C only, then B and C only. Then here in the middle is for the 3. So the moment you see a number here in this middle part for the 3 intersecting circles, all overlapping circles, we say that 5 belongs to set A, set B, and set C. Now, what disturbs people when they are writing in set notation? When you don't want to write A only, you can come here and say that. Means that the moment I say that I want members in senior 3 only, so it means that I want students in senior 3, but not senior 1 students, senior 2 students, senior 5 students, senior 4 students, senior 6 students. So that means that this is the complement part. A only, it can be written as A intersection B complement intersection C complement. So that is same as A but not B but not C. As I told you earlier in our introduction, that the word complement means that one is not part, or you are going to exclude it. Then also here C only, it is A intersection complement, intersection B complement, intersection C. So you want elements in C but not in A and B. Still in the scenario, the moment you see the word but not, you exclude that one by putting a complement in mathematics. Then B only, you come and say A complement, intersection B, intersection C. So as long as you see complement, that means that those two are not part of my working. Then also come here and say A intersection B intersection C. So that means that this is B intersection C only, because what I see having the complement is only A. So that means that A is not part. So how do you exclude that A? By getting B intersection C minus this one for the intersection of the 3. A intersection B intersection C. And for more information, this part here make up B intersection C. This part here, these two make up A intersection C. But A intersection C only, get this one for the 3, subtract it from A intersection C. So that is it. So be careful when you are writing in set notation form. And again, you have to be very careful with such words. At most, at least. At most means maximum. So the moment they say at most 2, that is 2 and below. Then they say at least 2, then that is starting from 2 and above. Or it is same as greater than or equal to, or less than or greater than or equal to, that is at least. Then less than or equal to, that is at most. Being greater than or equal to for at least, that means that that value is a minimum value. And then be having less or equal to, that means that it is at most or the maximum. Then also there is one, when you, before drawing a Venn diagram, please first put a title. As I told you, in this element of construct, data and probability, make sure that you draw you write a title, whether for matrices, whether for graphs, whether for statistics, whether for histogram and algebra. Talk about a histogram, talk about a scatter graph, talk about a pie chart, talk about a bar graph. Put there a title. Then don't write a matrix without a title still. So that's why I'm insisting on a title, because this data and probability, whereby they're expecting you to present, and how will people know what you are presenting without giving it a title? So also draw overlapping circles with a pair of compasses. Don't just use your hands and pencil to draw the overlapping circles. Please use a compass. Then after drawing your circles, enclose them in a rectangle, well drawn straight with a ruler. Then show all your working from the answer sheets. Because there is no way you just, in the Venn diagram I'm seeing X, but on the second diagram I'm seeing the value of X. So I'm asking myself, where did you get that X from? It is possible that one may suspect that so and so copied. And then after drawing a Venn diagram, let us make sure that you draw another Venn diagram without any knowns. Good enough. This Venn diagram has been explained. So nothing much. So you can see neither. This, the whole of this makes set C. Then the whole of this make set A. The whole of this make set B. Then also, as I had told you that when you are attempting this item for sets, all items under data and probability, whether matrices, whether statistics, whether graphs, a title should be in your mind. Never write, never draw a frequency distribution table without a title. Never draw a Venn diagram without a title. Never draw a graph without a title. Never write a matrix still without a title. So my friend, a title in data and probability is very important. And now that data and probability is all about presentation. So what have you presented? You have also to inform people what you presented by giving your table, your matrix, your Venn diagram, your graph, a title. Then after, draw a rectangle. You can see mine there. Then after drawing, you draw you can draw overlapping circles first, then you enclose them in a rectangle. So for the case of two sets, you can see there. Yes. So you can see that this is set C only, then this is set B only. Means I want elements which are in B but not in what? In C. So it means that I exclude this set C. I take members of B only. Then here it means that those elements do not belong to any of these two sets. Then universal title. Where is set B? The whole of this. Where is set C? The whole of this. Then here in between, those are the elements which belong to set B and set C. Okay, we are doing one example of set theory. So kindly pay attention as you watch this video. And we want to see everyone mastering this item of set theory. So here is our example 1. And then this is our scenario. A tour and travel company wanted to find out whether to organize a tour in the cities of Dubai, Cairo, and Paris. The tour would only be organized if the probability of a person having visited at least two cities was less than 50%. Among the people who submitted their visiting proposals at the company's head office, 41 had visited Dubai, 39 had visited Cairo, 15 had visited Paris and Cairo, 8 had visited Paris and Dubai only. The number of people who had visited Dubai and Cairo only were twice the number of people who had visited Cairo only. Additionally, 74 had visited at least one city, 4 people had visited other 3 cities, and a certain number of people had never visited any of the 3 cities. So we have our task here which says, find the total number of people who had visited Roman 1, Paris, Roman 2 had not visited any of the 3 cities. Then part B says, based on the calculations, advise the company's travel agent whether to organize the tour or not. Give a reason for your answer. So After reading your scenario once, don't finish. At least it would be better to read your scenario at least 2 times or twice. So you have to get back such that you extract your important information, because you will not keep on again reading the scenario. But after extracting all the important information, then you can be able to do your calculations with ease. So number 1, extract the information using set notation. So we are going to come and we extract. You can see that there are 90 people, the entire group. So that means that 90 is going to be our universal. And then we have those who had visited Dubai. So number of D is 41. And then number of P, those who had visited Paris, is not there in the question, but they are asking us in the task. So I've let it to be W. What you don't have, you let it. The number of those who had visited Paris, but not Dubai and Cairo, all those who had visited Paris only, have let it to be Z. And then those who had visited Dubai only have also let it to be Y. Then those who had visited Cairo, from the question you can see it is 39. It is here, 39. Then 41 for Dubai. Then 90 for Universal. And then A, 15 had visited Paris and Cairo. So you having that statement, 15 had visited Cairo and Paris. Don't go ahead and put 15 in the region of Paris and Cairo only. Now, if you don't see the word only, you have to get the number of people who had visited all the 3 cities. You subtract it from this 15. Get number of people who had visited Cairo and Paris only. Then similarly, here we have 80 had visited Paris and Dubai only. So that means that if 8 had visited Paris and Dubai only, that means that they visited Paris, and Dubai, but not Cairo. There are 3 cities. So if they visited that too, means that 8 had not visited Cairo. So we say that is 8. The moment you see complement, that means that you exclude that part. It is not part of your working. Then also this statement has caught my attention, and all people who would fail this number, the issues would come from this statement, that the number of people who had visited Dubai and Cairo only were twice the number of people who had visited Cairo only. But note this, that I don't have that number, so we can proceed. Then here 74 had visited at least 1 city, and 4 had visited all the 3 cities. So you can see that I have P intersection D intersection C is equal to 4. Then 74 had visited at least 1 city. Come and see. The moment they say at least 1 city, it means that from those 74, some had visited only 1, some had visited 2 cities, and also some had visited 3 cities. And that is P, union D, union C. And the answer is 74. Then also this statement that I've told you that whoever would fail this number, the issues would come from this statement. That the number of people who had visited Dubai and Cairo only were twice the number of people who had visited Cairo only. Now it depends on which one you let here. Now like me, I said, let the number of those who had visited Cairo only be X. So that's why you are seeing me having those who had visited Cairo and Dubai only as 2x. But when I let this one Cairo and Dubai only be x, now this one is x divided by 2. If I'm twice as old as your age, then it means that you are half of my age. So it depends how modulate. Then also want to go ahead and reflect on this last statement. A certain number of people who had never visited any of the 3 cities. Now that I don't have it, I've also let it to be K. Now, after extracting your information, go ahead and also insert your information in a Venn diagram. But before, as you know that in this element of construct, data and probability, where we find matrices, statistics, graphs, and then set theory, you must write a title, because it is all about presentation. So it's better you put a title for someone to be informed of what you are trying to present. Whether a histogram, put a title. A matrix, just say a matrix showing items board. A frequency distribution table showing the heads of senior 3 students. A Venn diagram showing number of farmers who grow different crops. You mentioned them, but a title should be very important. And you can see, like mine, from what we have been discussing, this is my title. A Venn diagram showing number of people who had visited Dubai, Cairo, and Paris. Or a Venn diagram showing number of people who had visited the 3 cities, Dubai, Cairo, and Paris. And then after writing a title, then someone can easily know what is there on a Venn diagram. Because in the Venn diagram, make sure that you draw the overlapping circles with a pair of compasses and a pencil. Then also you must make sure that you enclose the circles in a rectangle, as you can see mine there. So this is my universal here. 41 had visited Dubai, then W had visited Paris, because we don't know it. Then K had not visited any of the 3 cities. Then 49 had not visited, 39 had visited Cairo. Then here 4 had visited. It's better when you are representing, inserting your data on a Venn diagram. You start with this one for the 3, the region for the 3 the region intersection for the 3 sets. It's better you start with that one, because after putting here a 4, you can now detect this 11, because they are saying that 15 had visited Paris and Cairo, but not 15 had visited Paris and Cairo only. So here we need to subtract 4 from 15 and get 11, the one you are seeing here. Then 8, those ones had visited Dubai and Paris only. Then Y had visited Dubai only. Then Z had visited Paris only. Then X had visited Paris, Cairo only, and then 2X had visited Dubai and Cairo only. But you can recall the other statement that the number of people who had visited Dubai and Cairo only were twice those who had visited Cairo only. So you can say that here I have X, and then I have 2X. So after inserting your information, it's better you calculate or you find the value of those unknowns. But it's not a must that for you, most learners, know only one to find the value of those unknowns in a Venn diagram, that you equate to the universal. Not every set. You can equate to the universal if at all you have only one unknown in all regions. But now that here we have Z, we have here Y, we have X and K, so there is no need of us equating to universal. But identify from the 3 sets, which set can you use for you to have an equation having only one unknown. And if I consider this, you can say that I have x and y. If I equate it to 41, if I use this one now, I'll have also two unknowns, moreover not having w at the same time z. But the moment I use set c, for those who had visited Cairo, you can see that 2x plus 4 plus 11 plus x, I get 39. And I remain with only one unknown, that is x. So it's better you study your Venn diagram and see what you can use to find the value of the unknown. So from the Venn diagram, we are going to find now the value of those unknowns. But subtitles in mathematics are very important. So it's better also don't writing 4 plus 11 plus 2x plus x is equal to 39. And then I ask myself, what is this learner intending to do? But when you put there a subtitle, finding the value of x or the value of x, then I may not ask myself. So here from that set C, 4 plus 11 plus 2x plus c, x is equal to 39. So you collect like terms. Goats together, cows together. So constants here we have 4 and 11. And then variables we have 2x and x. 4 and 11, I get 15. Then 2x plus x, I get 3x. Then here I collect like terms. Minus 15 minus 15, I get 3x as 24. And the value of x is equal to 8. Then the value of y here is 41 minus the sum of 8 plus 4 plus 2x. And the answer here is 13. Then finding the value of z now, you have to make sure that you see what can I use to find the value of z. I've said that D union P union C is equal to 74. So I'm going to add all regions making that union part, D union C union P, and now you equate it to 74. So I have Z, I have 4, I have 8, I have 13, I have 2x, I have x, I have 11, then is equal to 74. But x is known as 8. That's why you are seeing me having 16 and 8, and I'm getting a total of 60 subtracted from 74. I get z as 14. Then also we can find the value of w, the number of those who had visited Paris, and also they are asking us that number. So here we have 8 plus 4 plus 11 plus 14. I get the answer as 37. Then the last value, the last unknown is k. So it means that if 74 had visited at least one, then that means that the remainder from the 90 had not visited any of the 3 cities. That's why you see me getting 90 minus 74, getting a difference of 16. Make sure that all regions of Venn diagram are catered for. Don't leave it there. Don't leave any region not known. However much you may not be, they may not ask you to find that region, but make sure that you complete all regions by filling their numbers, not unknowns. So after finding the value of those unknowns, you redraw a Venn diagram showing all regions without a single unknown. And here is mine. Bring back your title as you see it, a Venn diagram showing number of people had visited Dubai, Cairo, and Paris. So follow the procedures of drawing the overlapping circles, enclosed in a rectangle, well drawn using a pencil and a ruler. You must be neat in mathematics and organized. So here we are. Let me fill them. Yes. So you can see that 41 had visited Cairo, then 90, total number of people, 13 had visited Dubai only, then 8 had visited Dubai and Paris only, 4 had visited other 3, 16 had visited Dubai and Cairo only, and then 8 had visited Cairo only. And if you recall the other statement that those who had visited Dubai and Cairo only were twice those who had visited Cairo only. And indeed, you are seeing that here we have 8, then here we have 16. Then here 11 had visited Paris and Cairo only. Yet in the question we had that 15 had visited Paris and Cairo. So you don't land here your 15. We only land it there if it had only that 15 had visited Paris and Cairo only. Now that we don't have only, always subtract this figure in the region for the three, in the region for the intersection of the three sets. And then 16 had not visited any of the three cities, and then 14 had visited Paris only. So how do you confirm whether your set is right? Go and check every set and see. You can see that 16 plus 4, that is 20, then plus 13, that is 33, plus 8, 41. Even come here, 16 plus 14 plus 4, 18, plus 8, that is 26, then plus 11, 37, and I have it here. Come here also, 11 plus 4, that is 15, plus 16, 31, then plus 8, 39, also right. Even here, 16. Now, don't prove each set and you see that it is right. You say that everything is done. Go ahead and now add all the regions of sets, including the one there in the nether part. And it would be better to start with it because most people forget it. Because it is outside those three circles, even most people also fail that number of sets by forgetting that number in the nether part. Again, add everything. If you don't get 90, then you have to come back and review your work. So that's how also we can do that. But so here we have our part A and part B, but part A has 2 parts in our task. So our task 1, so these are the responses, because there is no how to respond before completing our Venn diagram by filling all regions with constants without a single unknown in it. So here, these are the responses, and then part A was asking Roman 1 that find the number of people who had visited Paris, and we got 37. So here we shall say that 37 people had visited Paris. Always give a conclusion, whether it is number 1, number 2, number 3, number 4, number 5, number 6. In all sections, make sure that you give a conclusion because they award a mark for it. So the moment you fail to put it there, you lose out some scores. Then Roman 2 says of part A that find the number of people who had not visited any of the 3 cities. And we have seen that 16 people had not visited any of the 3 cities. We got this 16 as the value of K by subtracting 74 from 90. Then part B was saying, help the company's travel agent to know whether a tour will be organized or not, and give a reason to support your answer. But they had a condition saying that if the probability that a person had visited at least 2 cities is less than 50%, a tour will be organized. So here we are seeing probability of a person who had visited at least 2 cities. The word at least, as I told you earlier, means the minimum. So we are going to look at those, the number of people who had visited a minimum of 2 cities. So those who had visited 2 cities and 3, because in our cities that we have, there are only 3. So greater than 2 and above would also write 5, but now here we have only 2. We have only 3 cities. So which how many people had visited exactly 2 cities? I have 16 for Dubai and Cairo only. I have 8 for Dubai and Paris only. Then I have 11 for Cairo and Paris only. Then plus 4, now 2 and above, so also 3. Those that visited the 3 cities are also 4. So probability is the ratio of expected outcomes to total outcomes. Number of expected outcomes divided by number of sample space. So now that we are dealing with percentages, may I have multiplied 100 at once. And now if you add 16 plus 4, 20, plus 8 plus 11, 31, then plus 8, 39. And you can see that I have 39 out of 90 times 100. Then the answer is 43.33%. But ask yourself, is it less than 50%? Yes. So the tour will be organized. But now come and give a conclusion. And you can see mine here. The tour will be organized because the probability that a person had visited at least 2 cities is 43.33%, which is less than the given percentage, which is 50%. So this is that I've helped the company travel agent know why, to know whether the tour will be organized, and the reason is also here. Because the probability that person had visited at least 2 cities is 43%, which is less than the given percentage. So thank you so much for watching. And I want us to keep on practicing. Don't give up, and also keep watching. Inform your friend also to learn from us. And also, after practicing the questions that I'm going to bring last, also you can WhatsApp me on the numbers that we had, that I gave you as I was introducing this lesson, and then we shall be able also to give the feedback. So here are the 2 numbers that we are going to discuss. After doing them, you can also share them on my WhatsApp number, or both numbers are on WhatsApp. Where I get stuck, also we can be able to give support. So here our activity number 1 says, the school is wishing to offer bursaries to sportsmen and women as long as more than 60% play at least one of the games in football, netball, basketball, while more than 40% must know how to play at least 2 of the 3 games. It was discovered that out of 100 students who had applied, 40 students played football, 45 played netball, while 50 played basketball. 24 played football and netball, 18 played football and basketball, and 19 played basketball and netball, while 18 students who applied did not know how to play any of the 3 games. And then here, the task. Basing on calculations from the information above, advise whether the school should offer sports bursaries. Then calculate the probability that a student picked at random played only one sport game. So task 2 Activity 2 says, a city's transport department is working on improving traffic and public transport for a busy industrial area where 124 workers commute daily. They have conducted a survey to understand the preferred modes of transport used by the workers. The findings have revealed that 32 workers use buses, 50 use motorcycles, and 72 walk to work. Some workers use more than one mode of transport. 15 use both buses and walk. So you can see that here there is no only. So you must subtract those who used all the three modes. Then 18 use both buses and motorcycles, the same. Then 7 use both motorcycles and walk. Then 4 use only buses. So this statement simply means that 4 use buses but not motorcycles and do not walk. So here, while the number of workers who use none of the three transport modes exceeds those who use both motorcycles and walk only by 3. So the transport planners claim that they will put traffic lights only if the chance of those who only exceeds 40%. So the transport planners want to analyze this data and optimize the road usage and reduce congestion, especially during the peak hours. So the task here is determine the number of workers who use all the three modes of transport. And then part B says calculate the probability that a randomly selected worker uses at least 2 of the 3 transport modes. And then last part, advise the transport department based on your calculation whether to put lights. So thanks for watching. I'm still assuring you that getting an A is possible. Don't give up. Keep practicing. The best solution for mathematics is to passionately practice it daily, and you also see the good results from that love that you have activated for the subject. Thanks so much for watching. We meet next time.